Okay, cool. So the question is, I'll just start with the question. We are sending a space probe to a planet to measure temperature and send the data back to Earth.
Got it.
We have bandwidth to send only 100 bytes of data per day. We can measure, yes. So the bandwidth between that planet and Earth is limited. The probe can measure temperature how many times you want. That's not a limitation, but the data transfer is limited.
The measurement is not limited, but the data transfer is limited.
Yes, if you want, you can measure 200 times a day and do some processing. You can do whatever you want. Just the data that is being sent to Earth can be sent only 100 times per day. Sorry, 100 bytes per day.
Got it.
Now, scientists are going to use this temperature data to answer various questions like, is the temperature suitable for humans to live? Does the planet have little difference in temperature from day to night, like Venus? Or a moderate amount of difference, like Earth? Or huge, like Mercury, where the difference is some 400 degrees or so? And does the temperature change slowly or abruptly throughout the day? Right? Can you make predictions? For example, you can say the peak temperature in Bangalore over May will be between 36 and 40 degrees. Can you make predictions like this for that planet? Or does it change so randomly you can't predict?
Got it.
Right? These are the these are some examples of questions that scientists would want to know. They would ask, right, based on the data. And these are not the only questions, right? Scientists can come up with new questions later on. After the data is sent, at which point you cannot reprogram the probe. You program it once when it is on Earth, then you send it. Then you can't change the program. So you have to write an extensible program so that scientists have as much flexibility as possible to do different kinds of analysis, which are not possible to foresee now. For example, they may want to know whether the planet has seasons. Right? All of these open-ended questions. And this is a logic question, not a coding question. Like if it helps you to write code to explain the concept, that's fine, but code is not required.
Okay, got it.
So that is the question.
Got it. Okay, got it. So if we start with the 100 bytes per day, that limitation, so all these prediction logic, somehow we calculate the temperature difference. For example, let's say in 24 hours, we take the difference between each hour, and we store 24 an array of 24 temperature. So we just pass the temperature data to Earth, but it 20. So okay, let's consider an array of 24 values will be I am considering 4 bytes, so it comes around.
So you are going to send an integer?
Yes, correct.
What data type are you going to send? Okay.
I will send an consequent values of 24 different values, an array of 24 values. So that will have each, for example, 10 a.m. to 11 a.m. What was the temperature difference? So that I will send it in Celsius or Fahrenheit. So with that, I'll compute the prediction logic.
You're going to send the temperature difference or the temperature?
Either will work, I guess. Because if I send the temperature at that particular time to, because I think we can neglect the difference between an hour, and we can just take an overall 24 hours when we can have a predictable value. What was the overall weather over there?
So you're going to send one temperature reading for each day? I didn't understand.
Each day.
So you're not going to use the 100 bytes, you're going to send only one data point back to Earth.
Yeah, correct.
But then scientists want Okay.
That prediction logic we can have in our Earth, right, Karthik? So if we have the temperature, 24 hours temperature data, so I'm not going to send one temperature data of per day. So that will be not predictable, right? So I will send 24 hours, each hour what was the temperature at one point. So for example, 10 a.m., 11 a.m. like that. Each at start of the hour, 24 values, I'll send back to the Earth. So each day I will send that day of the temperature of the
Got
day.
it. Got it. So basically every hour you are sending one data point.
Correct. So in that case, we don't need to write all the code and send it to probe. In that, if we have all the temperature data, in that way, we can predict, we can add solution to it.
Got it. What are the pros and cons of this solution?
Yes, I think that's I'm noting down. The pros will be we will have like this the prediction, the assumptions, Karthik. The assumptions overhead can be avoided. For example, we were talking about how in the prediction itself there were multiple assumptions we need to make, whether it is livable, the difference was so huge, very small. So all those logic we can reach up to the mark, but still there might be few cases which we will lose out. So if you are passing the transferring the data, temperature data from our side, we can still make numerous amount of prediction. So that is one of the pro. The cons is, let's say, as per my logic, 10 a.m., 11 a.m., 12 a.m. like that. But if you want specific time or specific calculations, for example, let's say what I thought was, let's say the temperature is too extreme between 10 a.m. to 12 noon. But that also we can calculate. But how extreme, how gradually the temperature is increasing, that point we won't be able to consider. For example, 10 a.m. to 11 a.m., the temperature difference would have been 50 degrees. But how gradually it increased? Was it so harsh? That very detailing things we won't be able to calculate or observe.
Right. So then how can we improve this solution?
So now I'm sending a delta value of, so I'm sending 24 values now. So if we increase it to x, for example, each half an hour, so instead of 24 values, it is 48. 10 to 10:30, 10:30 to 11, like that. To 24 hours, half an hour division. If I send it, it will be 48. But it will increase the bandwidth. For example, we have a limitation of 96 to 100 bytes, right? But if I increase it, it will overcome our 2x. It will exhaust our bandwidth value. So what we can do is, will compression encoding kind of thing works, because if I send a raw data, maybe it will be 96 bytes. If I compress it to, for example, a character value which will take only 1 byte, then from our side in Earth we can decode it. So in that case, I can send more data in the given bandwidth, but here we can decode it.
Okay, how would you compress it?
So for example, Karthik, instead of sending it as 24, we can somehow come up with an encoding logic which will convert it into a string. Instead of let's say one digit is taking 4 bytes, a number type is. So if we use like a character, it will take 1 byte. So somehow some encoding logic, if we come up with, we can send more values. Like instead of sending 1 hour difference, I can send half an hour difference.
Right. So please come up with some encoding logic.
Okay. Okay, 10 a.m. to 11 a.m. Let's say the temperature 10 a.m. to 11 a.m. The temperature is 24. So 24. Let's say it is taking 24. So one basic encoding what I'm thinking of is, let's say 10 a.m. to 11 a.m. the average temperature or the starting temperature at 10 a.m. is 24 degrees, Karthik. So I will take the 24 equivalent is the character value is 24. So I will just take the TF and it will be a character and it will be just 2 bytes instead of taking the digit. It will be so my idea is like this, Karthik, to convert it into a string.
I didn't understand how this conversion works.
Okay. But the core logic is clear, right? I think basically the
No,
encode.
it's not actually.
I'm trying
Like
to
I
see.
understand you can encode, but I don't know how the encoding works.
Okay, yeah. Even I'm not able to explain it properly. But is my idea of encoding or compression sounds good? So the idea is instead of sending each R value, I can send per R 2 values. So and the compression idea is to send more values in the given
Right, let
bandwidth.
me listen to the specifics of the idea, then we'll evaluate it at the end of the call.
Okay. I want to pass on this encoding. Even I'm not able to come up with properly this encoding idea, but this is what my overall thought process is.
Okay, do you want to try some idea other than encoding?
Okay, let me try. Since initially I have said that prediction logic will not be in the probe, I can't send like an overall average, like a single value, like it is cold, it is hot, it is livable, it is not livable. Because if I send livable, our scientists can't predict saying that why it is not livable, because it is so cold or because it is so hot. So is it too so
Or
how,
both? Maybe it is too cold at night and too hot in the day.
yes, so that will be a problem if I send just the temperature. How different, for example, the night it have been too cold, but still we could have, but in the morning how hot it is it a livable temperature? So I can't send just a single day value, also single point value. How can we improve this? Multiple values. If I take multiple values of temperature per day, I can't send because of bandwidth limit. Okay. How about this, Karthik? Okay. Let's say 30th Jan data will be split into 2 or 3 days. So it's not necessary, like it's not like a real-time value where per day it should come. What I can do is I can calculate the data. For example, instead of per hour 2 times, maybe I can take 4 times, 15 minutes once I'll take the value and I'll send it. But 30th Jan value will be split into 3 days, 3 parts. So first part will be given by 1st February, second part, 2nd February, third. So the latency will be of 3 days. So the 30th Jan weather data, we can get all the data of, so we can send multiple points, and 3 days. So all the day of all the temperature data of 30th Jan will be received in our station 3rd February. So we can calculate and we can write the prediction also.
So latency is one aspect. But then if 30th data is going to be sent on first, what about first data?
Let's say 1/3 of the data only we would have got. Second, so it will take 3 days to have a complete set of data.
No, I get that. So are you going to send 300 bytes per day split over 3 days instead of 100 bytes per day?
Let's say the data is 300 bytes, Karthik. So I will exhaust 100 into 3 days. Yes, that's the idea.
But then what about the second day and the third day? You're not going to measure temperature?
It will happen, Karthik, but each day it will take 3, x plus 3. The x is the day plus 3. When that
No, I'm not No, not asking about latency. What I'm asking is 30th Jan data, if it takes 300 bytes, then you send it on 30th Jan, 1st and 2nd. Then first data, when will you send? You'll send it on 3rd and
Yes.
4th and 5th.
Yes.
So you're creating a backlog, and the backlog is getting bigger and bigger because you can send only 100, but you're sending 300. I'll give you an analogy, right? If I can drink 1 cup of tea every day and I order 2 per day, what will happen? Today's 2nd cup I will keep for tomorrow, but tomorrow 2 will come. So then there'll be a backlog of 3. Then next day there'll be, so the backlog will keep increasing and increasing and increasing, right? Because you're generating more data than you can send.
Okay. Yes, that will be a problem. What I assumed was, so what I thought was, in our probe, the storage capacity will be maximum, only the sending bandwidth will be less.
No, that is fine, but no matter how many gigabytes you have, you're just creating a backlog.
No,
and you'll never be able to exhaust that backlog.
But as soon as the first day, 30th Jan data is transmitted, I can remove it from the cache, right?
Yes, but then more data gets added to the cache faster than you can remove it. Yes. Every day you are adding 300 bytes, but removing only 100 bytes. So it will keep increasing, and you'll never be able to catch up.
Got it. Let's, at 10th day of temperature, the cache, okay, at one point it will definitely get exhausted.
Yeah. So even if you have infinite cache space, what is the point? Because you'll never be able to send all that data back to us.
Okay.
If the probe is going to last for 10 years, only first 3.5 years or 3.33 years worth of data can be sent. The rest will, the probe will die before the bandwidth is available to send, right?
Yes. Okay. Let me think of some other solution. Okay. I need to find the optimal range difference instead of sending. Okay. I'll try for another 5 minutes. I think if not, we'll.
Yeah. If you want, you can take more time.
Okay.
An interview tip: don't give up before the interviewer says that we need to stop.
Okay.
Because if you give more time, you may be able to solve it. Whereas if you give up, he will not give you a mark for this interview question, right?
So I am standing with my assumption, Karthik. So still I don't want to write my prediction logic in the probe system. I still want
I agree with that.
I still want to just send the data, and I want to have my prediction logic in the station. So just I need to come up with the manipulation logic of data in the bandwidth.
Yes.
Okay, so let's start attacking my first approach disadvantage, where the predictability will be very vague since I'm just sending an R delta. So let's optimize that process. Okay, instead of 10 a.m. to 11 a.m. at one point, what if I want to send 2 points itself? I'm exhausting my bandwidth limit. If I don't want to exhaust the bandwidth limit, one idea is I thought of encoding. What could be other? I thought of sending the data in a splitted way, so it will create more latency and it beats the point of cache issue.
Encoding is the right approach.
Okay. Encoding, but I'm just thinking how to encode it. 24-degree. Okay. So I need to. I need to revise on this memory management concept. I'm getting confused between how 24 will be actually stored in our CPU memory. If I know that means it would have been easier to write an encoding algorithm.
Let me know if you want a hint.
Okay, okay. Oh, okay. Since our all our storages are binary, so 24 will be represented. Four bits of bytes. Yeah, Karthik. If there is a hint, it will be easy. It will be helpful. I'm stuck.
Yeah. So let's say I'm a student. I have a budget of 100 rupees every month to buy notebooks. And I am buying 2 notebooks for 50 rupees each every month. But I need more than 2 notebooks. How can I do it?
The budget is 100 rupees, and each month you are buying 2 notebooks for 50 rupees.
But I need 3 notebooks because I am attending 3 classes, let's say.
Okay. One naive approach, one naive solution I'm coming up with, let's say the 2 notebooks is 180 page, 180 page. So you can go with either 3 150 page, which will be 100 rupees like that.
So basically you're saying buy cheaper notebooks.
The notebooks with lesser paper.
Right. So when we say cheaper, it could be cheaper because it's lesser paper, lower quality paper, smaller size of page, any reason. But whatever it is, you are saying that I should buy cheaper notebooks so that I can buy 3. Correct? So how can we apply that logic here?
Yes, instead of sending it as an integer or number types, we can send it as a char types.
Okay. How many bytes does a char take?
1 byte.
Okay. And how would you encode it? Like what value of the char means what? Are you familiar with the size of an 8-bit integer? What's the minimum value, maximum value, etc.?
8-bit integer.
Or X-bit integer in general?
No, Karthik.
Okay.
I'm not very confident. Yes.
Okay. So let me give you that information. See if you can help. See if you can solve it.
Okay.
If you have, and you can write this down and start the screen share. If you have an unsigned integer of X bits, the maximum value is 2 power X minus 1.
Maximum value is 2 power X minus 1.
Yeah. Do you want to do it on the computer and do a screen share so that we have a record?
Yes. So an unsigned int, the max value is 2 power x minus 1.
If it's a signed int, do you know? Or shall I tell you?
Signed int max. Signed int max also should be 2 power x minus 1.
No, 2 power x minus 1 minus 1.
Minus 1 minus 1. Okay.
No, the first x minus 1 is in brackets.
Okay.
And the minimum value is minus 2 power x minus 1.
Okay.
Everything except the minus sign is in brackets. And put one more nested bracket after the caret.
Okay.
So basically for an 8-bit integer, if it is unsigned, it is 255. If it is signed, it's minus 128 to 127. Does this information help you?
Just a minute, you can just note it down. And if it is an unsigned
int 8. 0 to 255.
Signed means
minus 128 to 127.
Okay. This 0 to 255 is bits, right?
No, the minimum value and the maximum value are 0 and 255 respectively for an 8-bit unsigned integer.
Okay, okay.
I'm giving you the range of values.
Okay.
Based on this formula, can you tell me what, or just Google it, minimum and maximum values of a 4-byte integer? That'll be easier. Just Google it.
It is
There you go.
Okay, good. Okay. So based on this, we need to go with okay. So in order to use as less memory as possible, what I can do is go with this 1 byte I can do. And let's say I have a threshold. If it is less than minus 100 degree, or if it is greater than 100 degree, it is I don't need to send anything. So that will be the maximum limit I can send, 100 minus 100 like that. But if I don't send the precise value, it will be hard. So
no, I don't understand. What if the value is more than 100? You're going to not send it at all? What are you going to do?
no, I thought like that because if it is more than minus 100, I thought there is no point of sending it back because if it is non-livable. But if I don't send it, it is not right way to do it, right? Because if it is minus 4000, also I need to send it. It's not like I can put a threshold at negative and positive numbers. What I thought was my assumption was like if it is livable or not. But there might be other predictions as well as like this is the coldest planet in the world, the universe or this galaxy. So
minus 4000, eh?
Minus 4000 or minus 1000 like that.
Is that possible?
Okay, minus 1000 is not possible. There is no cold. Venus, what is the
The coldest temperature possible is minus 473 degrees.
okay? Got it.
And what's the maximum possible temperature? Can you have 10,000 degrees on a planet?
10,000 degrees. Not sure, Karthik. I think
The surface of the sun is 6,000 degrees.
yes. Okay.
How can a planet be hotter than the sun?
Yes, got it.
So
So
one of the things I'm looking for is
Hmm.
using common sense inputs like this.
Okay.
If I'm talking about measuring the population of a country, you should not assume it's going to be 10 billion people.
Because the world population itself is 7 or 8 billion.
Exactly. So any problem, the reason we are saying planet, when we say planet, we expect you to use your judgment.
So since we have this knowledge now, the coldest can be of minus 400 Celsius, and the maximum could be 6,000, less than 6,000 definitely, because the sun itself has the core of.
Do you know the Kelvin temperature scale?
Mhm.
It's same as Celsius, except that minus 273 is 0 Kelvin. So there are no negative numbers in the Kelvin scale. So let's use that so that it's easier.
Okay, in terms of Kelvin scale, we can send 0. Okay. Then we can use unsigned values of so 470 degrees Celsius.
Where did 470 come from?
The hottest, the coldest. See, hottest is 6,000.
Yeah. So basically assume 0 to 6,000 Kelvin or 7,000 Kelvin, something in that range.
0 to 6,000 Kelvin. Okay.
Yeah, it
So
won't be 6,000 Kelvin because that's almost a star. So now each temperature value is in this range of 0 to 6,000, let's say. Or whatever. If you want to go with some other assumption, go with some other assumption. That's
okay. Since it is like the hottest is the sun, I can go with like 4,000 Celsius.
okay, great. Just talk in Kelvin. Don't even bring up Celsius anymore.
Okay, Karthik. So
It's almost the same.
Okay. Since I'm going with 4,000 value, I need to go with 2 byte unsigned values.
We need to.
I go with 1 byte. The problem is I can go till 255 only. The but we just assume that it will be 0 to 4,000. So if I do okay.
So if 8 bytes is too small, is 16 bytes, sorry, if 8 bits is too small, it's not enough. Is 16 bits the only option?
No, we can go with 10 bits.
Okay, so is 10 enough?
We can go with 10 or this bits and bytes always confusing.
If you use 10 bits, it goes from 0 to 1023.
Okay. Then it won't be because our assumption is 4,000.
Then what will be?
Okay.
Answer is 12. 12 goes from 0 to 4095.
Okay. Okay, I need to go with 12 bits. Got it. So if I can use the 12 bits, I can.
So what's the benefit of using 12 bits as opposed to 4 bytes?
So 4 bytes will, so 1 byte is how many bits? 8 bits or 4 bits? 8 bits. So if it is 8 into 4, instead of 32 bits, we have reduced now it to 12 bits.
No, I know that, but the question is, what is the benefit of reducing?
Okay. Again, to have the lesser data type so that we can accommodate.
No, don't answer in the abstract. Tell me concretely what is the benefit here. Earlier, you could capture one reading per hour. Now, can you capture more? If so, how many more?
So initially, I thought of capturing 24. That will be 24 into 4 into 6. Instead of using next, so since I was 100. In 1200 bits, I was sending 24 data points.
Where did 1200 bits come from? We have 100 bytes, which is 800 bits. That is the amount of space we have.
800 bits. Okay. Okay, just a minute. Oh, I multiplied 100 by 12 instead of 8. Okay, just a minute. Now I have 800 bits. I am not very sure. Can we send 75, approximately 75 data per day now?
Calculate it 75 times. How many bits is each?
12.
Yeah, do the calculation.
Almost like close to 70 data I can send.
Give me an exact answer.
Okay. 66.
Right. So what is the advantage of sending 66 measurements instead of 24?
Now we have more data points, right? For example, let's say now since I have 66, I 66 divided by 24. So I can take closely like 3 data per hour. So like 20 minutes, each 20 minutes I can send, I can get the data and I can calculate the delta, or I can just send for this hour 3 values. So based on that, we can, okay, from this value to this value, this has been extrapolated. We can analyze and observe, visualize the data even more. We have more freedom to visualize the data.
Right. Let's say the scientists are telling you that they need more than 67 data points per day.
More than 67. Okay. Now we need to go even more lesser space than 12-bit unassigned unsigned values. How can we do that? more than 66. We can't go less than 12 bits because of the assumption we made 0 to 4000. In that case, can we reduce the assumption to instead of 0 to 4000? Can we make 0
No.
to 4000? No.
Then it might be very hard. We don't know.
Okay. So we can't take away the assumption of 0 to 4000. Still, we won't move
Or
data.
it could be very cold. It could be close to 0. We don't know.
Okay. Again, I think that encoding will come into picture, Karthik. But I don't know how. Not sure. That's why I hesitate to answer. But somehow, if we make the 12 bytes, since 1 byte is 8 bits, and now we are sending 12 bits of data. Maybe if we somehow, let's say that logic we come up with, that encoding logic, it will be, let's say each data will be 1 byte. So I theoretically, we made 12 bits to 8 bits. So 100 instead of 66, now we can send 100 data.
If you want, I can give you a hint.
Okay.
Or do you want to give up and do you want me to tell the solution? That's also fine.
No, Karthik, I'll go with the hint and I'll write.
You already gave me the answer earlier, but then you ignored it.
Oh, let me go through my notes. Not sure, Karthik.
Send the differences instead of each value by itself.
Sorry, Karthik?
Send the differences between two subsequent values rather than each value separate.
Okay.
That was the solution you came up with earlier.
Why
will this help?
Sorry, Karthik?
Why will this solution work?
Let's say at 10 a.m. it is 20 degrees. Let's say at 10:20 it is 30 degrees. Let's say, okay, instead of sending the difference if I send, but I need the reference. I'm not very sure because, but if I send, very confusing. $10 a.m. to 10:20 difference, 10:20 to 10:40 difference, 10:40 to 11 difference. How this will be more efficient? Why it is efficient? Difference. Basically, why the difference can be efficient means instead of sending 24, 28, 32, the difference will be 4, 4, 4, 4, 4. So
exactly.
So basically the value that holding that index will be lesser of size.
Exactly. So how many bits would you allocate to each?
Okay.
Earlier we were using 12. Now how much will you allocate?
This part I'm not very sure. because the difference can be 2 digits or 3 digits. So based on that, we need to assign bits. So based on maximum bit difference, maximum digit difference, we need to allocate the bits. Not very sure, but I think it is 8 bits.
Make an assumption.
Okay.
Like, yeah, if the temperature suddenly varies from 0 to 4,000, your algorithm may not be able to handle it, but assume that doesn't happen.
Okay, it is 0 to 4,000. So it will be, still it will be 12 bits, right? Because the difference.
No, what I'm saying is, assume that won't happen.
Oh, okay.
Assume the temperature reading, the temperature difference between two successive readings is within some limit.
Oh, okay. In that case,
is that a sensible assumption to make?
Again, like we said, using the common sense, I have not read more about astro, all these things. But if let's say I assume, let's say there in our galaxy, no planet has such a extreme difference. Like in 15 minutes, 20 minutes, 1,000 degree will happen. If it doesn't happen, we can go with the 1 byte unsigned value. So I will consider maximum it can go, the difference will be 255, 250, like that. So in that case, we can use 1 byte unassigned value, which is 8 bits.
You're on the right track, but there's one case it doesn't handle.
Okay. Okay. Let's say in the extreme temperature.
No, not extreme. Normal case, which happens every day on Earth in every city.
Peak time, Karthik. Like, let's say 30 degrees is the peak in Bangalore. So at that daily happen.
No?
Because 30, so let's say 30 and 32 fluctuations happening, still it will be lesser value, the difference will be.
What if it goes from 32 to 30?
32 to 30.
30.
Minus values. No, 32 to 30, it is still gradual, right, Karthik? The difference will be very less.
Yes, but you're using an unsigned integer, right?
Yes. Okay. Oh, I assume that it will be just okay. What I thought was 32 to, even if it is negative, I need to send negative. So in that case, unsigned 1 byte value we can. See, signed.
So then what is the assumption?
Assumption will be the maximum difference will be minus 128 in this case, and the highest difference will be 127.
Right. Cool. So let's do this. Shall I analyze how you perform?
Yes.
First, so there are two types of engineers, the application engineers and system engineers. Application engineers are what 90% of engineers are. And most of programming is getting data from one place to another, showing it, handling errors, retries, all this stuff, right? Object-oriented design. It's not like hardcore algorithms and bits and bytes, right? So most engineers are application engineers, but the system engineers are the ones who can build high-performance software that processes maybe a gigabyte of data every second, or consumes very little battery, right? The most optimized, or handles huge amount of data, right? Like the kind of people who build Google search algorithms. These are system engineers, or build a database or operating system, this kind of low-level stuff.
Okay.
A system engineer is expected to answer this without any input from my side.
Got it.
An application engineer is supposed to handle it with some input from my side. But I felt I had to give too much input to you.
Okay.
So that is one thing. The other thing is, it's always okay to ask any number of questions to the interviewer. Just say, hey, I should know this, but I don't. So I'll ask you a few questions. Based on that, I will answer. How many bits are in a byte? What's the minimum value? What's the maximum value of 8 bits? Whatever. Ask those questions or Google it.
Okay.
Just tell the interviewer, hey, I'll Google it. That's better than asking him, because better to find it out yourself. And just tell him ahead of time, hey, I'm going to Google this and I'll do a screen share so you can also see what I'm doing. Because in real life exercises, we always have Google search available to us.
Yes.
And Stack Overflow and all these resources. So there's nothing wrong with using these resources. Just disclose it and do a screen share and do it. Think about, see, your job is to get to the answer. A person who uses Google search for part of it, right? I mean, not Google search the entire problem, right? But Google search one part of it. In this case, this is not a standard problem that you can Google search. Suppose I ask you how do you reverse a linked list. You should not Google search how to reverse a linked list, because then you're just reading out the solution. But one part of it, if you don't know, you can always Google search.
Sure.
So your intuition was correct. And often you were speaking without thinking, like signed versus unsigned.
Oh, okay.
Always think, write it down if you're not sure, speak. Or if not, say, hey, I'm just thinking aloud, give me a second, and then think aloud and then confirm it and say, yes, that is correct. Or no, that's not correct. Let me change it this way.
Got it. Sure.
Right? Let me see if I have any other parts. Are you not feeling alert today, or tired, or feeling down or something?
No, Karthik, I am alert.
Because when you gave up quickly, I thought maybe you're not kind of feeling good today or something.
No.
Fine. So let me see what else I can comment about this. You understood the problem. You had the right intuition of encoding. The bits and bytes thing is okay if you don't know, right? But I felt, yeah, I mean, once I give you a help, right, then you should have taken it forward. That is the only thing that can be improved.
Okay.
So anyway, so this is good. Shall I tell you my solution?
Yeah, Karthik.
So here I've assumed that let me do a screen share. Can you stop?
Yes, Karthik.
Do you see it?
Yes.
So let's assume that the temperature range is 0 to 6,000 Kelvin. In this case, I made this assumption. And always think about how you can encode data to make it simple for you. Especially getting rid of things like negative values. So that is one thing. And let's assume there's a level of precision in temperature below which scientists are not interested. So suppose I say the temperature on Venus has increased from 470 to 471 degrees. That is not interesting to scientists, right? So there is some threshold below which we are not interested. Right? Do you care that the temperature in Bangalore right now is 27.6234 degrees? No, right? That's too much detail.
Yes.
Or the temperature, the thermometer itself would have some inaccuracy. If the thermometer is accurate to 5 degrees, then anything less than that, there's no point sending the data back to Earth because it's noise, not data.
Yes, it's a noise data. Yes.
Yeah. So if the accuracy is 0.1 degrees, then there are 6,001, which is 0 to 6,000 times 10 different temperature values for each degree. Okay? So 60,010 values. But on the other hand, if you assume the thermometer is accurate to 2 degrees, let's assume that, right? So whether it says 20 or 21, it's not a meaningful difference. 20 and 22 is a meaningful difference.
20 and 22, yes.
So now there are 6,001 by 2 different temperature values, right? If you count from 0 to 4 all the way to 6,000, there are 3,000 values, right? And the number of bits in an unsigned integer, this is a formula. C of log of this. So you get 12 bits.
Okay.
So if you are assuming that the temperature ranges from 0 to 6,000, and the thermometer is accurate to 2 degrees, then you need 12 bits. Now, there's a trade-off between spatial and temporal accuracy. So one of the things you should do in an interview is, if there's any trade-off, you should point out. So fundamentally, if you have more and more readings, you have less space available for each reading, which means that it may not be accurate.
Okay.
So for example, if you want to prioritize spatial accuracy, each sample would have 12 bits, which means you can have 66 different readings over the course of a day, right? This is the same number you ended up with. Alternatively, if the scientists say, no, I want a value every 10 minutes I want to measure, then we will use the same differential encoding and assume the scientists haven't told me anything. I'm just making an assumption by myself. Then I would assume plus or minus 100 degrees. Then it will be an 8-bit, it will be a byte, right? Same thing as you. Now question is, let me ask you this. So suppose the value increases by more than 128 degrees at a particular time. Suppose it increases by 200 degrees, right? So 9 o'clock, it is 0 degrees. The next reading is 200 degrees. Now you can't send 200.
Yes.
You'll send 127.
Yes.
But then the next reading, suppose it increased by 10 degrees. Then you will send a difference of 10. But when you send the data back to Earth, when it is reconstructed, that 10 will be added to 127. And it will be 137, whereas actually it was 210. So if the actual values are 0, 200, 210.
210, we will be calculating it as 137.
Yes. So what you should do in such a case is, if the variation exceeds the maximum limit, whatever you can send, you send. The remaining value you keep in a buffer, and in the next reading you accommodate. So first time when it increased by 200, you are sending that it increased by 127. Second time, the remaining value, 63, you are going to add to the difference. So when it increased by 10 degrees, you're going to send the data back to us saying that it increased by 10 plus 63 degrees, 73 degrees.
Okay. Okay.
Then when you add that to 127, you'll end up with 210.
Yes, got it. Got it, Karthik. Understood.
Otherwise, what happens? If one data point is wrong, the entire day's data is wrong. So algorithm should be self-correcting. If they go wrong, they should fix themselves.
Got it.
And we can tweak this however we want. If scientists say they want 200 readings per day, then we can allocate fewer bits to each. And make an assumption that it won't vary by more than 50 degrees or whatever the number is, you can calculate. So there are many variants of this, right? Another algorithm would be measure the temperature every second. Not every hour, not every minute, every second. Okay? And then for every hour, send 2 data points, the minimum and the maximum temperature. So part of the processing is being done on the planet, but rest of it on Earth. Right?
I'm just processing this point, Karthik.
Pun not intended.
Seriously not intended. Okay, we will just send the minimum and maximum of the temperature at each hour clocked.
So 9 to 10 a.m., what is the minimum temperature? What is the maximum temperature in this time period?
Okay.
Then 10 to 11, then so on.
Oh, got it. Okay.
So because suppose suddenly something changes over 1 minute or 2 minutes, let's say a volcano erupts and in 1 minute the temperature increases. You want to capture that. Whereas in all the earlier things, such fine-grained data we cannot send because there's no space.
Yes.
And of course, if you know something about the planet, you can always use that. If you know the temperature never crosses 200 degrees, suppose Neptune or something, right? It's so far from the sun and so cold. So you can assume some maximum temperature, not 4000 Kelvin.
Okay.
Or suppose you're sending it to Venus, you know it changes gradually. Then you can assume that it never changes by more than 10 degrees per hour. So etc. So anyway, this is a very low level question. It is typically not asked. I like this question because there's a lot of room for creativity. It's not that there's only one answer. Like find the biggest subarray with some value, some constraint. There's only one answer.
Yes. Cool, Karthik. I have noted down all the takeaways and learning from this, like asking as much questions as possible before saying it anything. It is completely fine to think out loud, but if when I'm saying, I will always think it through and give my final answer. Then pointing out the trade-offs, then the algorithm should be self-correcting.
Yes. Because if you're designing a car, for example, there's a trade-off between fuel efficiency and performance. If you want to design a car that goes till 300 kilometers per hour, it won't be fuel efficient. So these kind of trade-offs need to be pointed out because then everyone will understand which is more important and so on.
Yes.
Some interesting facts about planets, if you're interested, before we conclude this.
Yeah, I think sure.
On Venus, the temperature doesn't change much from day to night.
Oh.
Because Venus's atmosphere is like 100 times thicker than our atmosphere. It's almost like a liquid, not like a gas.
Okay.
So it is so thick that whichever side the sun is shining, it will redistribute the heat across the entire planet.
Oh.
And Mercury, which is closest to the sun, you expect it to be very hot, right? It reaches minus 120 or something at night.
I didn't know this. I didn't know this. I always thought Mercury is the hottest in our galaxy.
Because it doesn't have an atmosphere, at night it cools down very quickly. The atmosphere acts as a blanket. So temperature changes slowly.
Oh,
without an atmosphere,
is very low, it is not able to wrap up, or there is no pressure of.
Exactly. So whenever it goes towards night, it is not exposed to the sun, it is exposed to space. Immediately the heat all drains out.
Got it.
And daytime, sun facing, it goes to like 400 degrees or something Celsius.
Okay.
And yeah, all these interesting things are there. And there's one planet where it is so hot, in the daytime, iron melts.
Okay.
Not only does it melt, it vaporizes. It's that hot.
Oh.
And in the night, the vapor condenses to liquid and liquid iron rains.
Okay.
There's another planet where it rains diamonds.
Jupiter.
I think so.
Jupiter.
Anyway, so yeah. So do you have any more comments on this question or the way I've conducted the interview for that matter before we move on?
No, Karthik. It was really helpful. I understood how the process would be. Even I got more enthusiastic, and it was one of the more engaging interview rather than just
Thanks.
about the optimal approach. It was like a more open-ended question and coming up with more solution coming up with more hints, optimization. It was very fun and knowledgeable.
Great. And one thing to think about is think about your interviewer as an ally, not an opponent. If you can't solve it by yourself, that's okay. Take his help and solve it.
Sure.
he will still be happy that, okay, I gave him some information, but based on that, he reached a solution, which is a sign of a good engineer. Because nobody knows everything there is to know. A good engineer builds on other information, be it other people in the team, be it online resources, be it a book, whatever, to get to the solution. So think about that.
Sure.
So if somebody asks me a question about some domain which I don't know, let's say seismographic analysis.
Okay.
I will make some assumptions. I would ask, is this valid, etc., etc. Or I would ask him for some information.
Sure, Kath. We'll do that.
Okay. Just stop the screen share.